Thanks, Grace. So I'm here today to talk to you about release strategies. Now, a lot of the time here at developer conferences, we like to talk about coding and the ins and outs of coding, but we don't often talk about how we actually get our code from on our desktops across and onto machines. I want to talk to you a little bit about why you should be thinking a little bit more carefully about your release strategies. Release strategies are at the core of building great software today. Great release strategies can be a major point of differentiation for your product or service. Let's just go through some examples of some companies that have stood out from the crowd as a result of good release strategies. Tesla. So Tesla cars, unlike a lot of cars today, get over-the-air software updates. This means that you can be getting new features, unlocking new features for your car and for the AV system of the car without having to take it into a dealership where they'll pop the hood and connect in some connectors and whatever else. By moving to a release frequency more akin to web applications, Tesla has really revolutionized cars, partially through that and partially through a whole bunch of other things, but one thing is the release strategy. Let's talk about Chrome. Chrome really shook up the browser world through moving to an evergreen model. Who here uses Chrome as their primary browser? Yeah, so most of the room, right? And Chrome didn't exist not too many years ago. One of the reasons why they became a dominant browser is their release frequency, their ability to be able to push out new features and get them automatically updated on the machines, on the end user machines. They became a major player in the market, mostly through a really great release strategy. Let's talk about Facebook. Facebook were really famous for move fast and break things. They've kind of shortened the motto now to move fast because I guess they're scared about breaking things when they have a billion people using it. But it's clear that release frequency and a strong release strategy was at the core of Facebook becoming a dominant social network. So I think the release strategies are very important and something that you should be thinking about when you're working out how to improve the way that you build software. So I'm going to run through in this talk 5 strategies for improving your releases to reduce the risk associated with releases and extract more value from your releases. I'll be talking about release frequency, I'll be talking about visibility, progressive rollouts, I'll be talking about monitoring, focused monitoring, and A/B releases. Let's get started. So to start off with, I'm going to talk about high frequency. High frequency is at the core of a highly effective release strategy. It forces you to automate away the bulk of the work, which frees you up to be able to work on better things and has a huge number of benefits. To start with, you have less software inventory. Software inventory is lost opportunity. These are features and bug fixes that you have coded, you've got them onto master, and you're just waiting to be able to get them out the door so that your customers can use them. Anything that's just sitting in source control but isn't out in the hands of customers such that they can take advantage of those new features and bug fixes you've built is just lost opportunity. It's waste. It's pretty rare in our industry, but this is a big problem. Lower mean time to resolution. So if you can release more frequently, when you come across a problem, it's a lot easier for you to be able to fix it and get that fix into the hands of your customers. It's akin to going from your local mechanic's multi-hour process for changing out tires where you have to go down the street and have a coffee and chat to some friends and check your Facebook and then finally be able to pick up your car, to going to F1's pit stop where you pull in, 10 seconds later, new tires, off you go. Lower mean time to resolution is very important if you want to run a critical service. Reducing busy work. So high release frequency just forces you to automate away the bulk of the work. If you want to release multiple times a day, but you have a release checklist that is miles long, you just can't get through it in time to be able to release multiple times per day. The less time that you spend manually FTPing files around or SSHing into servers to be able to restart things and whatever is time that you can then spend on more important things. And I think at the key and at the heart of improving your release frequency is reducing the risk per release. Releasing new software is probably one of the most dangerous things we do and the thing that's most likely to bring down our services. So I think that releasing more frequently reduces the risk per release pretty significantly, as it moves the problem of finding the root cause when something goes wrong from a needle in a haystack problem to a much easier proposition of looking through one or two things. Let's just go through some examples of what that looks like. So you only need one bad apple to be able to cause an incident. If you're releasing a lot of things at the same time, identifying that root cause can be very difficult. You have to go through each one and be able to discard the apples and say, oh no, that one's good, this is good. Wait, here is the one. And then you can finally start to work on a resolution. If you're releasing a lot of things at the same time, this will become really difficult. Let's say you have a week or 2 weeks worth of change from hundreds of developers. There's just too much changes to be able to easily eyeball and understand what is broken. So if you just release a couple of things at a time, it's much, much easier to find that problematic commit or code change and be able to determine a remediation, a rollback or a roll forward or a feature flag flip. And think of it kind of like fixing a broken build. If you're building once per commit, it's really easy to be able to say, okay, this is the bad commit, let's revert that commit, we've got a green build, let's go on. But if you have a build that's building against a week, 2 week, a month's worth of change, and that build goes red with thousands of broken tests, trying to understand what the causes are of those broken tests is stupidly painful. So as you grow your team and scale out your organization, you will inevitably have more things to release. You're going to have more people cutting code, more people trying to get changes out there. And the only way to be able to mitigate the risks associated with those releases is to have more of them. Cut more releases with fewer changes so that you can get that code out there with isolated changes. So when you do have a problem, it's much easier to fix it. So this is something that we've been focusing on Confluence, and I'll just show you this graph. We used to release about once a week. And as part of that release process, we had a huge amount of manual work, big long checklists. We would have a lot of long-running builds that would be frequently read, very hard to be able to fix up. And we'd have a lot of cancelled releases. So that would mean that we would go near to the end of the week, we'd struggle to get a green build or struggle because there's some problems happening on our dogfooding environments that we can't understand, so we can't safely get that release out the door. But we've spent a huge amount of work trying to do that, and then we have to do it again the next week. We then roll all of those changes into the next week's worth of changes, and we now have 2 weeks worth of change going out the door. It's extremely risky. We found as we've automated away the bulk of the work and ramped up towards daily releases, which we've hit now, we have significantly fewer cancelled releases, and we spend a lot less time on building releases and shepherding them across the door, which gives us a huge amount of free time to be able to work on more important things. And now, going back to the risk associated, we actually saw a reduction or about the same amount of incidents, even though we have significantly increased our number of releases. So it's not releasing that is the thing that is risky in of itself. Releasing more frequently with smaller changes means that most of those releases are going to be successful. And when there are unsuccessful releases with incidents, it's much easier to be able to find out what's going on and fix it up. So to you, I say you should start measuring your release process today to understand where the bottlenecks are. Improving your release frequency is like improving a lot of things in software in that you need to measure first and then optimize. Find the bottlenecks in your process, fix them up, and iterate on them. Both Confluence and Jira Cloud have been going on this journey, and as I said, Confluence has gone from releasing every week to 2 weeks to releasing 4 times a week. And if you'd like to get there yourself, then just start measuring. Instagram also recently published a very great article about their release frequency journey as well, with very similar patterns and problems that we faced. So if you're not sure where to start, then that's a great read as well. Okay, so let's say you've hit high release frequency. If we're releasing multiple times a day, how do we make sure that we can answer the key questions about that release so that everybody's on the same page? Everybody wants to know what is going out in the next release, what has just gone out in that release, and it's not just developers, but it's also product managers, marketing, tech writers, everyone who's coordinating getting materials associated with that release out the door. We use Git tags pretty heavily as a way of giving this information to developers. Every time we cut a release, we put a new Git tag in the repository, and that means that if we want to find what releases a given commit is going out in, we can just do a simple git tag ---- contains command to be able to find out what releases that's going out in. We also automate adding the release information to the Jira issues mentioned in that release. That's really useful when you're trying to track when a bug fix is going to hit customers, so you can follow up with those customers who are affected by the bug so that they can go ahead with their day. But these communication steps mostly help developers. It's very hard to get marketing to be able to do a git tag contains command to be able to understand what's happening. So how do we deal with those other people? Anything large enough for these other people in our organization to care about, marketing, tech writers, product managers, is all behind a feature flag. Feature flags decouple the code release from the feature release. This means that we can put the code into production, ensure that it's there, and then use Confluence and HipChat to be able to coordinate the release of that software and flipping of that feature flag with those additional people. We want to make sure that it's safe before talking about it with a wider audience and publishing our marketing material. And we also want to make sure that we don't have the marketing material out before getting the docs out. Coordinating all those multiple people and those multiple processes can be very difficult without feature flags. We can also significantly reduce the risk by using progressive rollouts, which I will talk about now as the third release strategy. If you deploy a new feature that contains a bug to 100% of your customers, all of them are going to be waiting for you to fix that bug. However, if you only release it to 5%, then it's not as big a deal, right? Sure, those 5% are going to be quite angry with you, but 95% of your customers will be able to continue along with your day, and you have a little bit less pressure on you from the higher-ups to be able to fix those issues straight away. Progressive rollouts are a great way to reduce your blast radius. It's a real lifesaver. So we use feature flags to be able to enable progressive rollouts. Who here is using feature flags today as a way of managing their releases? Not too many of you, okay. So feature flags are usually implemented with a very simple if statement in your code or in multiple places of your code to flip between the old behavior and the new. You deploy this code to production dark. That means that whilst the code is present, it's dormant. The feature flag has not been enabled, so the old code path is being exercised, and to the end user, nothing has changed. And then when we're ready, we can turn on the flag at runtime, like a light switch. This means that when we turn it on, we can ensure that it's the only system change that's occurring, so that if things start to go wrong and we see some problems on our monitoring, then we have the ability to turn it off. And we also have the ability to know that, yes, it is this problem, this feature flag, because we just turned it on. Feature flags also enable progressive rollouts to subsets of your customer base because of the runtime configuration nature. So we can start off by turning on the feature for dog fooding only. So first within our own team and then to the wider Atlassian teams to be able to gather internal feedback and iterate on that feature whilst knowing that the code is safely dormant in production, so we can turn it on and off whenever we want. Once we've gathered our internal feedback, we can release to increasing subsets of our customers. This means that if we hit bugs or issues, we can pause the rollout, we can investigate, we can fix it, we can decide to turn off the feature flag and take that feature away so that we don't have to worry about all of production being affected. Finally, after releasing the feature to 100% of our customers, we can go back and clean up that feature flag code and remove those if statements from the code and make the new code path the default and delete out the old code path. We've been using this strategy internally for a large number of projects, from small projects that are internally facing, things that you can't see as an end user, like infrastructure changes for improving our release frequency. The seamless upgrades project for Jira and Confluence Cloud, which enabled daily upgrades that Julio Simon is going to be talking about tomorrow afternoon, was released in this manner. We also released feature additions like the new Confluence dashboard single page app work that Blake is going to be talking about. All the way up to very large scale releases with wide-reaching changes like Jira 7, all released using feature flags and progressive rollouts. It doesn't matter how small or large the change is, you can use this method and it will help you to be able to limit the blast radius of that change. So now we're releasing our code multiple times a day. We don't really want to be relying on on our customers telling us via Twitter when things are broken. We're releasing so frequently that we want to be able to know that things are good without having to rely on those customers coming and telling us, oh, your thing's broken, and then us having to scramble and work out, okay, when did they tweet? Was it 5 minutes ago? Was it 2 hours ago? What release went out then? Instead, we want to be able to have good runtime monitoring of our systems to be able to understand key features of that release and ensure that the release is good. So for this, we've been using focused monitoring. So what's focused monitoring? So to understand focused monitoring, I'll first explain unfocused monitoring. Unfocused monitoring is very low level, things that you normally capture from your systems, things like CPU, memory consumption, disk usage, I/O stats. There's a lot of metrics that we gather, and they give us a low-level picture of the health of those systems. Focused monitoring is about getting a higher level picture, something that you can understand from a customer level. It's very easy for you to have 0% CPU usage across your servers, which looks great, if no one can hit those servers. Or maybe all your pages are serving 100 milliseconds slower because you're logging out a stack trace on every request. That might show up as a blip on I/O stat or something on those servers, but is pretty unlikely. However, the customer impact is actually quite large because 100 milliseconds for every page hit it adds up. It becomes quite annoying. Everything can look normal on your servers as well, but maybe no one can interact with your application at all because the JavaScript is broken. So focused monitoring allows you to put in runtime monitoring so you can understand these things. So what should you be monitoring at this higher level? Some of this has overlap with analytics, and that's good, but sometimes you may use different systems for this because analytics is more around batch processing, whereas this you really need to have real-time monitoring. So things like critical customer flows, we'll monitor both for real-time monitoring and for analytics. We'll monitor things like page creations in Confluence, both successful and unsuccessful. We'll monitor for things like errors during startup. Perhaps an error during startup won't manifest itself as any end-user problem, but sometimes it does, and sometimes the upgrade will succeed, but there may be an error that's causing a certain part of the application to break. Performance is also a very important thing to monitor using this method. In addition to successful and failed page creations, we want to know how long it takes for people to create pages so that if we slip in a performance regression, we can see that. But the key thing for focused monitoring is to make it easy for developers to add monitoring. I can tell you what I think you might want to have to monitor, but really the best person to understand what you should be looking at during a release is the developers who are releasing code for that release. They will know the 1 to 2 things that might change as a result of their code changes, and they'll know what they want to validate, like what assumptions they want to validate about the release that they're pushing out. Make sure that they can easily add monitoring for these things and either get them to watch that rollout themselves or hand over the information to the team that's monitoring that rollout so that they know what to look for. And being able to watch changes in production is a really big motivator for your teams. So For example, we monitored how long it took to perform an upgrade as part of moving to daily upgrades to be able to minimize the downtime. Having a number that we could put on a wallboard and work down over time was a really great motivator for our team so that we could visualize and see that we were having a big impact on our customers' lives. So that was number 4. Let's talk about number 5, A/B releasing. So A/B releasing combines the ideas of progressive rollouts with focused monitoring so that you can run 2 code paths in production and verify that your refactors are safe. It allows you to test wide-scale back-end refactors with no user-facing impact while you're smoothing over the edge cases. So who here remembers spot the difference puzzles from papers or from being a child? Okay, Robin does, and only Robin. You and I, we're cool. You guys, not so much. So what you get is you get these 2 images side by side, and you have to like circle the things that are different. So you see that on one of them, the branch is missing. This flavor of release strategy is very similar to a spot the difference puzzle. You run both code paths and return the old one to the user, but you can spot the difference between the 2 to be able to make sure that the new code path behaves similar to the old code path. This is great if you're trying to break apart a monolith into microservices to verify that the new microservice performs and behaves the way that you expect compared to the existing monolith code. So how do you go about this? You start out by introducing the dormant code. Just like the feature flag stuff that I was talking about earlier, you put the code in, it's asleep in production, it hasn't been turned on, no user-facing impact, nothing's happening. Then what you do is you start running both the old and the new code for comparison. So this is a second mode. It's kind of a step above a feature flag where you, instead of just returning the new code path, you run both the old and the new, and you start to compare performance metrics and as well as correctness to make sure that it behaves the same. Then you progressively start to switch customers across to returning the new code path. So it goes, instead of running both the old and the new, you just return the new for a small subset of your customer base as you're getting increasing confidence in that new code path being successful. And then once you switch 100% of your customers to the new code path, you can delete out the old code path. So an example of this release strategy, we've been using this to transfer Confluence Search from Lucene on disk to an external Elasticsearch cluster-based search for Confluence Cloud. When a search request came in for Confluence, we would fire off a request in both the Lucene-based method and the Elasticsearch-based method. And we can return the Lucene results to the end users so they can see no difference. But this gave us an opportunity to be able to validate that the Elasticsearch cluster performed correctly, as well as the results being of high enough quality to be able to switch out from the old to the new, because Elasticsearch behaves slightly differently to Lucene in how we do the indexing. We then use the progressive rollout method to switch subsets of the customers across to the new results returned from Elasticsearch. And then once we switch everyone across to the Elasticsearch way, we can remove the old code path as well as clean up all the Lucene indexes that we have on disk. This enabled us to do a very large back-end refactor safely with high confidence, low risk, and with great monitoring to understand what's happening whilst we're performing that release. So there you have it. We covered 5 release strategies today. High frequency. You should start measuring today, remove the bottlenecks from your process, and release multiple times per day at minimum. That's where you should be trying to go. If you're currently releasing, say, once a quarter, that's the old way. Start releasing more frequently, get lower risk releases, get your fixes into the hands of customers faster. It's just in general better. Great visibility. So make sure that it's very easy for you to trace what's happening with releases in production, which is something that you need to automate away when you're moving to high frequency, as well as get everyone involved in the conversation using feature flags. Progressive rollouts, use feature flags, again, so that you can enable lower risk progressive rollouts across smaller subsets of your customer base so that you limit your blast radius. Focus monitoring. Make sure that your developers can add monitoring. It shouldn't be just the ops guys who are in charge of monitoring and looking at CPU usage. You should give developers the opportunity to be able to get metrics out of production. And A/B releasing. You're doing big, large-scale refactors. This is a great way to be able to make them nice and safe. I hope you've got a thing or two from this talk and go away and have a think about how you release software. Thanks a lot.